This is the first of 3 videos I'm going to upload to YouTube that cover a methodology in cryptology known as the RSA algorithm. And I wrote it a couple of years ago, and it was directed at laymen to the field of cryptology. And I want to give a slightly non-technical description of how it's created, and in the last video sort of explain some of the uses. RSA algorithm. The RSA algorithm is a numerical method in cryptology to encrypt private keys for PKI digital signing. As such, it utilizes some of the principles of algebraic sets and their relations. I'll try to explain in plain terms how one key is created. It was created by 3 mathematicians, Rivert, Salim, and Edelman, thus the name RSA algorithm. Those interested in its history can, of course, do a Google search of those 3 guys. I won't go into history here. To understand this algorithm, first we have to cover the modulus. So let's do that. The modulus is a way to relate number sets to each other using a base number to map one set to another. An example should illustrate the idea. The simplest example would be 1 equals 3 mod 2. What this means is if we only have 2 numbers we count with, 0 and 1, to represent larger numbers, we must put them in terms of 0 or 1. So 3 is just going 1 beyond 2. What would 4 be? 4 would be 2 twice, so it would be 0 again. How about 5? 5 would be 2 twice, then 1 more, so it would be 1. How about 6? 6 would be 2 3 times, so it would be 3, would be 0. Now let's put these examples together and show them below. I think you can see this without me reading it. When we go through the familiar 10 numbers of our base 10 system, starting with 0 and going to 9, we simply map them to 0 or 1 repeatedly. Notice on the left side, every time we increase the base 10 number, it keeps going between 0 and 1. This is because the only numbers we use in base 2 are 0 and 1. If the base is 10, we can use 0 to 9 different numbers. Beyond that, we could map smaller numbers to larger ones using the modulus again. An example of base 10 modulus, we can make the base 12. And then every number we count will have to be a multiple of 12. That is what the 12-hour clock does. Again, an example will show this. Midnight is 0, which equals 12 mod 12, though it's represented in the American system as 12. It might be worth noting that in other countries, there's a 24-hour clock, and you go around twice before you hit 0 again. So, as examples, 1 o'clock is 1, which is actually 13 mod 12. 2 o'clock is 2, which is 14 mod 12. And 3 o'clock is 3, which is 15 mod 12. So if you divided 12 into 15, what would be left over is, of course, 3. 4, it's kind of obvious. If we keep making this mapping, all the 10 numbers of base 10 would be used. But we won't. I think you get the idea. But here's a strange one. 1 equals 1/4 mod 5. This equation is not exactly integer division. It means we divide 5 by 4, the remainder is 1. Mods are always integers, so 1/4 of 5 is 1. You drop anything after the division. This is because RSA uses a fraction. This is important because RSA uses a fraction in its algorithm, and if this isn't clear now, when I give an actual numerical example below, it should be. And that's what we're going to cover in the next video.